So the integer types in Rust are these. We have the unsigned integers and then the signed integers. Unsigned simply means that they don't have any sign, they don't have negative signs, they are all positive. But signed means they can have positive and also negative. Let me give you an example. Let's say we create a variable and then we'll call it foo, and then we assign 6 to it. The first thing you notice here is that Rust will automatically assign i32 as the type of this variable, and i32 means signed int 32. Okay, so it means it is 32 bits and it is also signed. What it means is it can contain both positive and also negative numbers. And then if you print that to the terminal and then we run that code, you get foo is equal to -6. However, if we changed this and assigned something like u32 to it, it's not going to allow that, and you will see that it will say cannot apply unary operator minus, okay, negative to type u32. It means it is unsigned, so it can only be positive, it cannot be signed. And the name unsigned is actually gotten from, if you want to write a positive number, you can just say or write 6 without any sign. But if you want to represent a negative number, you must provide the sign. So that is where the signed and unsigned attribute comes from. So if it is just this way, then it is unsigned. First we have i8 or u8. So these are 8-bit types. They can only contain 8 bits, and so the maximum they can contain will be 256. Let me give you an example. So if you come in here and then you say that this variable is going to be I. Let's say foo is a type of i8. 8 means is an 8-bit data. It contains 8 bits. While I means it is signed. Therefore, it can contain a maximum of 128. Okay, if you try to assign 129 to it, it will start warning us, and then you say literal out of range of i8. The literal 129 does not fit into the type i8, whose range is between -128 and 127. What it simply means is that from 0 counting up, you can only use 128, and then counting back, you can only get to -128. That is exactly what it means here. Okay, it gives you some leeway in the positive side and also in the negative side because it is signed. Okay, if it is unsigned, then you can increment it to 255. Okay, including 0, which will make it technically 256. Now the next type you have will be I16, okay, or U16. Okay, this will hold 16-bit data of signed, while this one will hold unsigned 16-bit data. Then you also have the same way you will have I32. They're actually a multiple of 8, okay, and the equivalent U32. Then next will be I64, okay, and the equivalent U64. Okay, and then you also have I128, and then equivalent U128. So these are all the integer types you have in Rust. Then finally you have the I size or U size. So the size depends on the architecture of the computer you are using. So if you are using a 64-bit computer, then it will be U64, okay, U64, I64. However, if you are using a 32-bit system, then it will be U32 or I32. To be on the safe side, it's better you use I32 for the most part. And that is why if you create a variable without specifying the type, like here, Rust will automatically assign I32 as the type of the integer. Okay, next let's look at floating point numbers. In Rust, there are just two types for floating type numbers. It's either you use F64 or F32. Okay, but by default, Rust will use F64. So if you create a variable, let's call it bar, and then we assign something like 5.6, which is a floating point number, you find out that automatically Rust will assign F64 as the type. Okay, now you might be wondering why use F64 while if we created a variable of type int, okay, it will use i32 by default. The idea is actually that F64, the performance for F64 is not that different from F32, and F64 will contain more values than F32. Since you don't have much performance difference, it's okay to use i64 as the default. However, you can provide your own type for it. Okay, next we have the character type. This is used to store just one single alphabet. So for example, if we create a variable that we called a, and then we say it's going to be of type character, we can assign it to a single alphabet like T. Okay, notice that we used just single quotes, okay, instead of double quotes. We can do something like this. You can't use double quotes. It will point out that if you meant to write a char later on, use single quotes. Okay, so you have to use a single quote whenever you are defining a character later on. This is also good for storing emojis. So here we have an emoji. We can call it smile. Okay, and then we say it's a character, and then we paste that there. It can hold all characters as long as they are just a single character. Now, another thing that is very important for you to understand here is that a character holds 4 bytes. It occupies 4 bytes instead of just 1 for an int. Okay, it occupies 4 bytes every single time. So, and why it's important that it stores, it occupies up to 4 bytes is so that it can accommodate as many characters as possible, even Chinese characters, Japanese characters, and Korean characters. Okay, not just the English alphabet. So that way it can contain as many characters as possible. Then we have the Boolean type. This one is actually a no-brainer. It stores just true or false. For example, if today is Friday, you can just set it to true, okay, or false, and then you can provide the type Boolean. However, you spell it as bool. It can also hold not just true, it can also store false in it. Now let's talk about compound types in Rust. There are 2 compound types. Compound in the sense that they are like collection. Okay, they contain more than just one value. And there are 2 of them, a tuple and an array. Okay, so a tuple can hold a collection of value of different types. Okay, for example, let's create a tuple. Let's just call it top. Let's say this will contain a point, or let's just call it point. Okay, it will contain a data representing a point in a 3D space, which will contain an x-axis, y-axis, and then the z-axis. We can say it will be a type of tuple. The x-axis will be of type i32. The y-axis will be of type i32. Okay, let's just go with that for now, and then we can provide the value, say 4 and 5 for the y-axis. So we've succeeded in creating a tuple that will contain 2 values right here, 4 and 5. Okay, and the types for the first one will be i32. The type for the second one will be i32. You can also add a third one. You can add as many of them as you want. Let's say we want this one to be a floating point number, and then we say it will be of type F64. Then we can provide a floating point number, let's say 45.6. Okay, so this is how you create a tuple. It can hold as many values as you want. Collectively, all these values will be bound to point. Now, how do you access values from this tuple? You can just assign it using the dot notation. So let's say if you want to assign the x value, if you want to access the x value, which will be 4 in this case, you can just say point dot 0 since it's in the first position. It starts counting from 0. So point dot 0 will retrieve 4. And you can see that when we print this to the terminal. So if we run this code, it will say x is equal to 4. So it's reading this particular value. So point dot 0 will read the first value. Point dot 1 will read the second value. Point dot 2 will read the third value continuously. For example, if we change it to point dot 2 and then run the code, it will say 4 is 5.6, which means it was able to read the third value. Let's talk about what if a tuple doesn't have a value. This is also possible. Okay, in fact, a tuple can be empty. So right now we've created a tuple which will be of type a tuple, okay, but it's empty and nothing is there. Now Rust has a unique name for this. It is called a unit. It also represents something like void in other languages. Okay, for example, if you have a function that doesn't return anything, it will actually return an empty tuple called unit. So you can create an empty tuple without having any value in it, and that will be okay. Now, tuple is the first compound type in Rust. The second compound type is the array, and let's take a look at it. Okay, the difference is that an array will hold data of the same type, while in tuple you can provide different types of data in that block. Okay, for example, we can create an array of numbers, and then we say that this number will contain ith32. Okay, all the values inside this array will be of type ith32, and then you have to provide the length of that array beforehand. Let's say we say that it's going to have 4 values, and you separate that with a semicolon. Okay, and then you will go ahead and provide the values. Let's say 3, 4, 5, 6. So we've succeeded in creating an array that contains 4 values as is specified in the type, and all the values are of type ith32. That is one rule with arrays. All the types of the data inside, of the elements inside, must be of the type we provided here. Okay, if you provided a floating type here like f64, then all the values we provide here must be floating point values. Okay, and you can see if we print this to the terminal, if you try to print it the same way we printed numbers or integers, it's not going to allow it because the format is quite different. And in fact, if you look at it, it will say this array of this type doesn't implement the FMT display. In order to solve this, we have to use another format. Okay, we can just provide colon and then question mark, and that will allow us to print it and view it in the terminal. And if we run that, you will see that number is equal to 3, 4, 5, 6. The whole value is inside here. Now, it is possible in Rust. It is possible to create an array and assign values to it directly. Okay, let me show you what I mean. So in here, we can create a number and then say that we want to fill it in with 6. Okay, and the number of values inside will be 3. So right now we've succeeded in creating an array that will be filled with 6. Each of the elements will be 6, and then the length will be 3. If we also run that, you will see that we've created an array that is filled with 6 for each of the elements, and the number of elements in there is 3. So this is another way you can fill in an array while creating it without typing in the values manually. Now, it's important to know that arrays are actually fast because the values are stored in the stack, okay, thanks to the fact that we need to know the types and then the values beforehand. There's also a vector type which we'll look at in another video, okay. That one gives you a lot more room to do certain things like to change the values and all that. Now let's talk about how to access the values in an array, okay. Let's say we create an array of days of the week, and then we say that it's going to contain strings, string slices, okay, and then there will be 7 days in the week, okay, and then we'll go ahead and create the days of the week. So now we've created this variable, okay, an array that contains 7 values, okay. Each of the value will be a string slice, and then they will represent the days of the week. Now if we want to access the second day of the week, okay, remember that it starts counting from 0, so we can read the second value, okay, unlike a tuple that you can access by saying .1, which will be 0 and 1. For array, you have to use the block syntax, okay. You can then access the second one right here. Let's call it days of the week. If you print that to the terminal, you see that we got Tuesday, which is the second one. So this is how you access a value inside an array. So I did mention previously about the integer types, okay. Let's say we have a value here, and then say it's going to be of type I8, and then we assign 6 to it, okay. Now I know you must be wondering, what if this value is mutable, which means it grows, okay, and then we'll have a loop here that keeps incrementing that value by adding 1 to it this way, okay. What will happen once this A gets to 127? Will it get to 128? And the answer is no, because the memory allocated for this variable by Rust will be just 8 bits, okay. It's not going to grow more than 100 positive number of 127. Rather, it will overflow. It will start counting back from 0, okay. Now I would like to demonstrate this, but Rust is so smart. For example, if I try to say break out of this loop when A is greater than 130, or let's say just 130, okay, it will start warning me because A will never grow more than 130. If not, you'll find out that if you print A, the value of A afterwards, okay, once it goes to 130 right here, you find out that A would have overflown. Once it gets to 127, it will start back from 0 and so on. So you have to bear this in mind when you use the integer types and even the floating types, okay, and make sure that the value never gets more than the memory allocated to it. And that is why for most cases it's safer to use i32. It's very performant, okay, unless you are very sure it's not going to grow more than the memory space allocated to it by Rust.